Now that we're familiar with rational functions and how to find asymptotes and holes in the graphs, let's go ahead and actually graph some rational functions. So first, let's figure out where our asymptotes are. So and by the way, you might want to graph this, hit pause, and then check your answer. And obviously you want to be able to do this without a calculator, but we will check using a calculator later. So to find the vertical asymptotes, we need to try and factor the denominator. So let's start with our vertical asymptotes. So this is going to be x over, and this factors nicely to x minus 2 times x plus 1 in the denominator. So what is going to make the denominator 0? That's when x is equal to -1 or +2. So that tells me that I have vertical asymptotes there. What about horizontal asymptotes? Well, I need to look at the limit as x goes to positive and negative infinity. So what I need to do is look at the degree of the polynomials on top and bottom. And if the degree on the bottom is bigger, then the limit is going to be going to 0. So we have a horizontal asymptote at y equals 0, or in other words, the x-axis. All right, and there's no factors that cancel in the numerator and denominator, so there's no holes in the graph. So I think we have enough now to go ahead and graph our function. Now I'm going to look at the red factored form to help me with this. All right, so first of all, let's use a dashed line. So x equals -1, and I'm just going to do this by hand. Well, we know that that is a vertical asymptote, and then, should put some arrows, and then at x equals 2 is another one. Okay, and then y equals 0, or the x-axis. Guess maybe I should have done that in green, just to stay color-coded. Okay, so now we have to figure out what's going on with our graph. So I know so now I'm going to pick some values. So let's go with a different color. So I'm going to look at the factored form here. And as x gets big, let's say x is 10. I'm going to have 10 over 10 minus 2, which is 8, over 10 plus 1, which is 11. So 10 over 88. That's a positive value. That tells me that my graph is approaching the horizontal asymptote from above. We'll get some more specific details about that in a minute. Okay, what happens as x approaches +2, our asymptote? And I'm wondering what happens as we approach it from the right side. So what I'm going to do is look at some values. Let's say, I don't know, 2.1. We know the numerator is going to be positive. The denominator is going to be 2.1 minus 2 is a positive number, and 2.1 plus 1, 3.1, that's another positive number. So I don't really care about the values. I just care that I'm having a positive over a positive times a positive, which is a positive number. And as x gets closer to 2, this term here is getting smaller and smaller and smaller. And when we divide by a really small number, we get a really big number. So that tells me that my graph, as it approaches the asymptote from the right, is going way up to positive infinity. And then one more thing I like to do is pick a value close to there. I don't know, let's say maybe 4. If x is equal to 4, I'm going to get 4 over 4 minus 2 is 2. 4 plus 1 is 5. I get 4 over 10. So at 4, I'm getting a really small number there. So with that, I can draw that piece of my graph. Okay, let's look at the same idea. Let's look at negative infinity. So as I'm approaching negative infinity, really big negative numbers for x, the numerator is going to be negative, and the denominator is going to be a negative times a negative, which is a positive. So I'm going to get a negative over a positive, which is a negative. So I'm approaching 0, but from below. So I know that it's going to be going like this. for that piece over there. So let's get a little more accurate. Let's pick a number close to our asymptote. How about x equals -2? And if I plug in -2, I'm going to have a -2. -2 minus 2 is a -4. -2 plus 1 is a -1. So I'm going to get -2 over +4, or -1/2. So that gives me the point right there. And then what I can do is, as I move to the left, I'm approaching the asymptote from below, and also I'm approaching the vertical asymptote as I get closer and closer to x equals -1 from the left. All right, so it's just a good idea to pick at least one value that's kind of close to your asymptotes, so you don't get, for example, here, let me graph a piece of this, so you don't just do something like this, which is totally off. All right. So let's get rid of all these. Now what goes on in between the asymptotes? So that's what we need to figure out. Okay, so one of the things we can do is figure out the x-intercept. How do you figure out an x-intercept? Well, that's when you set y equal to 0. And so what would make this function 0? Well, it's a fraction. And a fraction is 0 when the numerator is 0. So in this case, if x equals 0, we're going to get y equals 0. So we know that my graph goes right through the origin, 0, 0. Okay, so what happens as we get close to -1 from the right, meaning a little bigger than -1? So like values like -0.5, and then maybe -0.9, and then -0.999, for example. So what happens when I plug those numbers in? Well, my numerator is going to be negative, and my denominator, I'm going to have a negative number minus 2 is another negative number, and then -0.999 plus 1 is a positive number. So a negative divided by a negative is a positive. So that tells me that as I get close to x equals -1 from the right side, that my graph is going to positive infinity. Which means it's going to be going this way with a similar analysis as x gets close to 2, but a little bit less than 2. And so just to highlight what I'm talking about there, as maybe I should use an arrow, I'm looking at x values getting closer and closer to -2. So maybe -1, -1.5, -1.9, positive 1.999. So numbers that are a little bit smaller than 2, but really close to 2, that's going to make this number really tiny, but it'll be negative. The numerator is going to be positive, and then 1.9 plus 1 is positive. So I'm going to get a positive over a negative, which is a negative. So that tells me that as x gets closer and closer to 2 from the left side of that asymptote, I'm going to negative infinity. And there's my graph. So now let's check and see how we did. So I already punched this in, x over x squared minus x minus 2. Let's do a zoom 6. And sure enough, we've got a pretty good graph looking right there. And it takes some practice. It's not super easy to get used to at first, but once you try a few of them, you get a little better and a little quicker at it, and it'll come along. So let's look at another one. Let's try and graph this one. Maybe it's a good time to hit pause here and try some of those techniques and then hit play and see how you did. All right, I'm going to start with the vertical asymptotes. So I'm going to factor the numerator and the denominator if possible. The numerator is the difference of two squares. The denominator, let's see, that would be an x minus 3 and an x plus 1. If you're having trouble with factoring, definitely it's something you want to spend some time on practicing that, because otherwise this is going to be really tough for you. All right, now, can we cancel any of these? Yes, we can cancel the x minus 3's. So what does that tell me? That tells me that there is a hole at x equals 3 in my graph, but not a vertical asymptote. And so I only have one vertical asymptote, and that's going to be at x equals -1. So I'm going to go ahead and graph that. There's x equals -1. And now let's look at the horizontal asymptotes. So for horizontal, we look at the limit as x goes to positive and negative infinity. And there's 3 possible cases. So we look at the degree of the numerator and denominator. If they're the same, then our horizontal asymptote is going to be y equals the ratio of those coefficients. And the coefficients are both 1. So y equal 1. So I know that this is going to be a horizontal asymptote for my graph. Okay. And we know there's a whole at 3. So now let's go ahead and pick some values. And so what I'm going to do here, I'm looking at x plus 3 over x plus 1. Because whatever we plug in for x, the x minus 3's are going to cancel each other out anyway. All right, so what would make this function 0? Well, this will equal 0 when x is -3. So I know that that's an x-intercept for me. How about a y-intercept? The y-intercept is when x equals 0. And so if I plug in x equals 0 into my function, I'm going to get -9 over -3, which is 3. So 0, 3, 2, 3. And that's pretty much all I'm going to need because I know what's going to happen here. So as x gets really big negatively, what's happening with x plus 3 over x plus 1? I'm going to get a really big negative number over another really big negative number, but the numerator is going to be slightly bigger than the denominator. So, I'm sorry, I said that backwards. So when I pick a number like, let's just try negative 100, and I plug that in, I'm going to get -97 over -99. That's a little bit less than 1, positive 1. That tells me that I'm getting closer and closer and closer to positive 1 from below. My numbers are always going to be a little bit smaller than -1. So I know the graph is going to be underneath there. And then likewise, what happens as x gets close to the vertical asymptote? As x approaches -1, so that would be from the left side, so like -1.1. And I'm plugging that into this function. And so I'm going to get, what do I get here? A positive 1.9. Oops. And I was supposed to write a plus 1 here. And that's going to give me a -0.1. And so notice, as I pick numbers closer and closer to -1, like -1.01, -1.0001, -1.00001, this denominator is going to get smaller and smaller, and dividing by a small number gives me a really big number. But the sign of this fraction, I have a positive over a negative, which is a negative. So I'm going to get a really big negative number, and that tells me that my graph is going down here, getting closer and closer to that vertical asymptote. I'm going to go ahead and quickly explain the other side as well. So what happens as x gets close to -1 from the right side? So those would be numbers like -0.9. Okay, so what happens when I add these? 3 minus 0.9 gives me a positive 2.1, and 1 minus 0.9 gives me a positive 0.1. Notice now they're both positive numbers. And as I pick numbers closer and closer to -1, like -0.99 or -0.99999, that my denominator gets smaller, which means my overall fraction gets bigger and bigger, and it's going to be positive really big, so it's going up to positive infinity. And likewise, finally, as x goes to infinity, as we pick really big numbers like positive 100, we're going to get 103 over 101, which is a number that's a little bit more than 1. If you want to go bigger, 1,003 over 1,001. But nevertheless, our numbers are always going to be a little bit bigger than 1, so we're a little bit above that horizontal asymptote. And then one last thing, remember we had a hole at x equals 3. So now I'm going to go ahead and take care of that. 1 at positive 3. 1, 2, 3. Right there. And so we'll just put a little open circle there. What is that value exactly? Well, if I use the simplified expression, I can plug in 3, and I get 6/4, or 1.5. And that's exactly where my hole is on my graph. So if we want, we can check with the calculator once again. And we'll put in, make sure you put these in parentheses, x squared minus 9 divided by x squared minus 2x minus 2x minus 3. And sure enough, there's our graph. And if I type in, if I hit trace and I type it at 3, notice there's no y value because we know there's a hole in the graph there. All right, hopefully you feel a little more comfortable with graphing these rational functions using your asymptotes and the holes in the graph if there are any. One last thing to mention. If the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph has what we call a slant or oblique asymptote, a slant asymptote. So here's an example. And let me refer back to the last 2 examples that we did. Notice in this one, the degree was higher in the bottom, in the denominator. We had squared in first power. And so when it's bigger in the denominator, as x gets really big, this expression goes to 0. And that was our horizontal asymptote. On the other hand, if I can move this over to that one. Oh, here it is. On the other hand, if the degrees are the same, then it's going to be the ratio of the coefficients, which is 1x squared over 1. So 1 over 1 is 1. So y equal 1 is my horizontal asymptote. And then the third case is this, where the degree is higher on top than the bottom. And in that case, the limit is infinity, which means as x gets really big or really small, our graph is going up to positive or negative infinity. But we do have some guidance on how it's traveling towards infinity. And that's what this oblique or slant asymptote is telling us. So what we do is we do some long division, or we can do synthetic division. Either way, I'll do long division just because people are less comfortable with that. What do I multiply x by to get x squared? I multiply by x, and then when I multiply, I get x squared minus x, parentheses, subtract, 0, so I bring down negative 2, and that's my remainder. So x minus 2 over x minus 1. So what happens, it turns out, if we throw out the remainder, because remember, we're talking about as x gets really big. As x gets really big, this fraction is getting really small, almost 0. And so what we're left with is just this part. So it turns out that our, let's do some different color. Let's go purple. It turns out that we have a slant asymptote. And it's going to be this value after we throw out the remainder. So y equal x is going to be a slant asymptote. Now if we check the other asymptotes for the vertical, we factor the top, and that's x minus 2, x plus 1. No factors cancel, so there's no holes in the graph. And then we know that whatever makes the denominator 0 is a vertical asymptote. So if x equals 1, put a dot there. X equals 1 is a vertical asymptote. And then, so for the horizontal asymptote, we already talked about going to infinity. So that's all we really need to know. Now, if we want, we can figure out what the x-intercepts are. And we get those by looking at this. What would make the numerator 0? When x equals 2, our function is 0. And when x equals negative 1, our function is 0. And then if we want to figure out what the y-intercept is, go back up to the original, and if we plug in 0 for x, we're going to get 0 and then 0 minus 2 over 0 minus 1. So that just equals 2. So that's right here. Okay, and then we have the vertical asymptote. I didn't draw in there, so let's draw that in there. At x equals 1. And we've got everything we need. And so this is what's going to happen with our graph. It gets closer to that slant asymptote. As we go down here, it gets closer to that vertical asymptote. Same thing here. You can go through and analyze. And curved it a little too much there. And then this gets closer that way. And so, if we want to check this, let's go ahead, let's just clear it. X squared minus x minus 2 divided by x minus 1. Make sure I typed it in correctly. And sure enough, there's our graph. And if you wanted, you could go ahead and graph the slant asymptote, y equal x. Maybe change the graphing style on this. Red's good. No, let's switch. Let's make it match my graph. And we just want a regular line there. Okay. And sure enough, there you go. Now remember, the graphing screen isn't square because of the number of pixels. If I could do a zoom square, so it would look, there we go, exactly like that. All right, so that's about all you need to know. The rest is just practice, and that's the best way to get good at these. So your assignment is 2.7, which starts on page 157.